So 2017 question 2b in relative velocity. Ship is moving north at 15 kilometers an hour, and this ship is P, so it's moving north 15 kilometers an hour, so no I, so just J, 0 I, plus it's moving north, so plus 15J. Q is 10 kilometers west of P and appears to be moving relative to P in a direction east 60 degrees south at 15√3 kilometers an hour. So they're giving us here the velocity of Q relative to P. So let's just look on a I and J axis where this is going. It's going east 60 degrees south. So east 60 degrees south. Let me just straighten that line up a bit. East 60 degrees south, so 60 in here. This is my I. And this is my J. So find the velocity of Q. Well, we're being given the velocity of Q relative to P here. It's 15√3 in the I direction. Now I is adjacent to the 60, so it's cos. I should have left a bit more room here. Just let me go a tiny bit left. Now, what is J? J is negative. We're going down here. You can see J is negative, so positive, negative here. Positive, negative. So minus 15√3, and J going down this way is opposite 60, so sine 60. Now, what the cos of 60 is a half. So we have 7.5 or 15/2, probably should have wrote 15/2, but 7.5√3, and the sine of 60 is √3/2, so that'll be 15√3√3, which is 15/3 is 45/2. Then my I, J. So 7.5√3 I minus 22.5 J is the velocity of Q relative to P. Coming across to the left, the velocity of Q relative to P is equal to the velocity of Q minus the velocity of P. So what do we have? We have the velocity of P, 0y plus 15J. We're looking for the velocity of Q, so let's just get the velocity of Q on its own. The velocity of Q is equal to the velocity of Q relative to P plus the velocity of P, bringing it to the left, which is equal to 7.5√3 with 0 in that direction, so 7.5√3I. And then in my J direction, I have, when we're adding these together, I have 15 minus the 22.5. So we write the two of those out, 15 minus 22.5 in the J direction. So 15 minus 22.5. So we're left with 7.5√3I minus 7.5 J. So the magnitude and velocity of the direction. So magnitude, the velocity of Q is equal to the square root of 7.5√3 squared plus 7.5 to be squared. And calculator use for that works out to be 15, actually exactly 15 kilometers an hour. And the inverse tan will give me the direction. The inverse tan of 7.5, this will work out evenly too, over 7.5√3 is 1/√3, and we know the inverse tan of 1/√3 is 30 degrees. Now, in what direction is that 30 degrees going? It's going south of east, because P is this way, Q relative to P is this way, so this is south of east. going down in that way. Okay, the second part of this question. 2 minutes after the time when P and Q are closest, P is east, theta north of Q. Find theta. So we're looking for an angle. And if Q can be seen from P for 12 minutes, find the distance between them at the end of this time. Okay, diagram's really important here. So Q is 10 kilometers west of P and appears to be moving in this direction at an angle of 60 degrees. Now, if I just continue it a bit past P, we know that when they're closest, this is when they're closest at this point, because it will perpendicular distance is the closest distance. So they're closest here, and at the right angle. So that would leave that angle being 30. Let's make a bigger 10 here. So we start by getting this closest distance here. Let's call it x. What have we got? We could use 60 or 30. Well, sine of 60 is equal to the sine of 60 is equal to O over H x over 10. So 10 sine 60 is that closest distance. 10 by root 3 over 2 is 5 root 3 kilometers. So that's the closest distance. So 2 minutes later, let's bring this line down here. 2 minutes later, let's say that's at this point here. We have an angle for P, and it's just go a line out like this. This might, so P is in this direction. So the angle we're looking for is this one here. I know it looks like a right angle, but it's not going to be anywhere near a right angle. Now, based on our alternate angles, this angle and this angle are the same. So we call this one A. If we can find A, 30 plus A is equal to theta. So let's have a look at finding angle A. So we have our new triangle. The right angle is at the bottom. A is at the top. So what, we've only got 5 root 3 so far in this triangle, so we definitely need something else. Now, we should be able to get this side here. Why? Because we have the speed that Q is traveling at. And what speed was Q traveling at? It was traveling at 15 root 3 kilometers an hour. And we're told 2 minutes later. Okay, so 2 minutes later, we'll be able to get that distance there. So 15 root 3 kilometers an hour by 2 over 60 will give me that distance there. That becomes a 4 on the bottom, and the 4 and the 2 will cancel. That becomes a 1, that becomes a 2, so we're left with root 3 over 2 for that side. And here, root 3 over 2. So that'll help me get A. What have I got here? I've got O and A. So the tan of A is equal to root 3 over 2 O divided by A, which is 5 root 3. So the inverse of that is, on a calculator, tan inverse that, A is equal to 5.7 degrees. So 30 plus A, 30 plus A is obviously 35.7 degrees. Now my diagram's not great. This line here just looks like it's coming from the north, but it should be more angled. So if Q could be seen from P, now here's P and here's Q at these 2 points for 12 minutes, that makes each one of these 6 minutes. Find the distance between them at the end of this time. So the distance is this line here. So we'll be able to work out this one. We have the drop down, the closest distance is the same as this one, 5 root 3. So we can get this side down here. We'll then be able to use Pythagoras to get PQ. So it's traveling at 15 root 3 kilometers an hour. And the time is 6 minutes. So 6 over 60. So it's 1.5 root 3. 1 over 10. So 1.5 root 3 is that bottom side. So a little triangle just to show where we're at. The bottom is 1.5 root 3. The side was 5. This one here, 5 root 3. So just using Pythagoras, the distance between P and Q is the square root of 5 root 3 to be squared plus 1.5 root 3 to be squared. And if you put that into a calculator, it comes out as 9.04, and that is in kilometers.